Welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep. Myself Phanindra, I am here to present the subject called Control Systems. Probably you all might know about me, however there are some students who are very new to the channel. So before going to the session, let me explain briefly about the program. As you all can see, we are here in the GATE Champion series, and of course multiple subjects have been already discussed, and today we are going to discuss about the control system. However, those students who attended my circuit theory classes, you might be really waiting for control system also. So what we do is, all the way we will cover the maximum number of concepts through the questions in 4 sessions. So before going to discuss the topics related to the control system, especially on basics as well as the time response analysis, I would quickly give introduction about myself. Right, so just for the people who doesn't know about myself, so let me quickly explain about myself here, so all of you can see. Please let me know whether audio and video both are clear to all of you. Audio and video both are clear to every one of you or not. So if you face any problem, please let me know. Rufina, is it everything is clear? Right, Karan Gupta, good evening. And Rohit Singh, good evening. Arvind Reddy, sir, don't take PYQs. Okay, Arvind, I am not going to take PYQs. Today will be a different session. Surely it will be a different session. 1 or 2 questions may come here and there. That will happen everywhere, because ultimately I want to give more concept in the different way. Today we will see the practical approach in the time response analysis. I am very sure many of you are really waiting for that. Okay, so please let me know audio and video, if both are clear, then we can move forward. So Rufina Begum, please let me know, how are you? After being long time, right? We have discussed about circuit theory long back, and I came almost after 3 weeks here, right? So clear. So let's quickly go to the next slide here. So as I was saying, these are the chapters which we mainly aim here. So it starts with the basics. Of course, this is going to be the first chapter, and we are going to mainly focus on signal flow graph and block diagram reduction. As I feel that many of you already know the concepts, so I will go a little bit fast. After that, we will mainly aim on the time response analysis. As I promised at the starting itself, we will going to discuss deeply about the time response analysis. Today definitely you will see a different approach. Okay, and of course we will try to cover all these chapters in different days. And as I was saying, tomorrow also we are going to take the, we are going to meet at the same time, that is 9 o'clock, right? So Hardik Saxena, good evening. Arvind Reddy, yes. So basics in the sense, obviously it will going to cover block diagram reduction and signal flow graph, because of course basics in the sense, don't expect me to teach the basics of control system here, correct? We are in champion series, so you should think like a champion, right? So already the basics were covered multiple times. However, if you really want to learn the control systems again from the basics, I sincerely suggest that you can watch the lectures on the BEP app. Okay, yes, Aravind and Rohit, good evening to everyone. Karan Gupta, good evening. Now as you can see, though it is 2015 question, I want to take this question through the signal flow graph and make you to understand. Just it is a revision kind of thing, because in signal flow graph, you and me, both of we know that it is not so difficult concept. But however, I need to make it for the new students. So let's wind it up very fast. Okay, right. Yes, I am discussing only questions, Arvind. So please try to answer this question. For the signal flow graph, whatever you can see here in the figure, which one of the following expression is equal to the transfer function, that is y of s by x2 of s? Of course x1 of s is 0. Just you have only 1 minute and try to make it here. Sir, please provide PDF also. Sure, Karan, once the class is over, then I will share the PDF even in the Telegram group also. Don't worry about that. So find the answer here. What would be the correct answer? Of course, this is signal flow graph. As it was said that you get the transfer function between y of s and x2 of s, provided that x1 of s is 0. That means switch off x1. So you need not to worry about x1. So let me erase this x1. Now when you erase this x1 here, so just let me ask a question to you. What is visible to you? It is a very simple graph, isn't it? And being my students, definitely you can answer very fast compared to me also. So see here, it is x2 of s, and I can select now this as node A. Let me call this as a node A here, and let me call this as a node B. Of course, let me call this as a node C here. Clear? So can you tell me, when we have when we don't have x1, that means when we delete x1 here, what are the number of forward paths we are going to have here? Sir, please share the Telegram link. Okay, so the Telegram link multiple times I told you, but anyway I'll share it to you once again. In the Telegram, just press like @ IN Guru, right? IN Guru 2022. Enough that it will automatically take you to the Telegram group. If you are not able to find, just mention @ IN Guru, automatically you will come to the Telegram group. So what would be the answer? Okay, very good, very good, very good, very fast. So first of all, you must understand the forward path gain here. So we know that monsoon gain formula says all the way here that, so look at that, this is a monsoon gain formula. As you all know that the transfer function can be given as Pk delta k by del, where Pk is considered as a gain, forward path gain of the kth path. Of course, delta k can be written as a delta without touching the kth forward path, correct? So I feel that every one of you know that, and many of the students have already answered that. Just to give me 1 minute so that the students who haven't answered this, they will also try to learn. And as I was saying, don't miss the class till the end. You will learn many topics in time response analysis today. So what is delta here? Obviously delta is nothing but determinant of the graph, which is actually nothing but 1 minus sum of individual loop gains plus sum of gain products of all combinations of two non-touching loop, and again alternatively plus sum of gain product of all combinations of three non-touching loops. Of course, it continues like this. When it comes to delta k, the same value of the formula we will use, but you should not touch the kth forward path. That's it. Very simple, right? Just to give me 1 minute here, let me wind up because you guys are very genius, so you completed very fast, right? So let me take, this is A and B and C here. So how many forward paths are there? So forward path means you will be starting from this input, all the way you will be traveling like this, correct? And then as x1 of s is 0, we don't consider this one, so remove this one. So this is the only forward path which will make you to reach to y of s. So that means I can say the forward path gain P1 is equal to, simply it is going to be 1 here, and this is G2, and without any tension I can say this is equal to G2. Finished, right? Now tell me how many individual loops are there here. So individual loops I can say, so start from here, you can start all the way from here, and when you go all the way, look at that, just give me 1 second. Yes, as you can see, you can travel from A and come to B here, and then again C, and then G1, correct? So likewise you can reach to A, of course B, and then C and A. Then it will going to frame a loop here. So what would be the gain of this loop here? Easy, gain of the loop is G2 and -1 and G1. So that means it will be having the G1, G2, of course -1 here, correct? So A we started and went to B and then came to C and end at A. That's why I made like loop 1, that is individual loop A, B, C, A, you will going to get this one, right? At the same time, what would be the loop 2 here? Loop 2 we can say, again, start from A, of course this is going to be A, and then from A we can all the way come like this. This is -1 and touches 1, and then again you will come to G1 and to come to A here. So therefore second loop is all the way A, C, A, and without any second thought, what would be the gain of this one? -1 into G1. So this will be simply like -1 here. Clear? So you guys have already done. So just let me go one step more than that, right? So now we can say the transfer function clearly as equal to Pk, that is P1 into delta 1 whole divided by delta here. So now can you tell me, fatapat here, P1 is known to you, what is the delta value here? So delta is equal to 1 minus loop gains of, sum of loop gains of individual loops. So this is the loop gain and this is the loop gain, correct? So therefore I can say this loop gain is minus G1, G2, and again this is going to be minus G1, all the way this will be equal to how much? 1 plus, I can say this as a G1, G2, and G1 you can take common, in fact it will going to become G1, G2 plus 1. Clear? So easy this is, right? Denominator is so easy. And when it comes to numerator, which is nothing but delta 1, what we should do? 1 minus sum of individual loop gains which are not going to touch the forward path 1. What is your answer? Sum of loop gains which are not touching the forward path 1. Now we all know that the forward path will travel between where to where? So it will definitely pass through A, right? So A and B, definitely, right? So therefore loop 1 is touching the forward path 1, loop 2 is also touching the forward path 1. This means we don't have any individual loop without touching the forward path 1. That's why I am making it as equal to 0. So then answer is very easy. What is P1 here? P1 is G2, delta 1 is 1 here. So let me write down 1 here, of course divided by 1 plus we can say this is G1, of course G1 into G2 plus 1, and I appreciate the students who have already done it. So what would be the correct answer here? Look at the correct answer here. So just give me 1 second. Yes, the correct answer is option B, and many of the students have already done. I am very happy about that. Now let's move on to the second question here. So don't expect that I am so slow, because I am a teacher. I need to explain such that everybody can understand, isn't it? It's not like only for some students. Now this is one more question I would like to take, and look at this question, every one of you. So what would be the correct answer for this? Now use your intelligence and make it fast here. For the signal flow graph shown in the figure, the value of C of S by R of S is dash. What would be the transfer function here? Now take just 1 minute and try to make it. So I will see how many of you can do it this very fast. So there are 4 options. Of course, this might be 1 mark question, but this relatively it will give some concept out of you. What would be the first option? First option, every time when you are writing here, write the transfer function is equal to, of course, Pk. In fact, I can say only one forward path gain is there here. So now R is there, and let me call this as x1 here, and x2 is the another node, and x3 is the another node, x4 and x5 C. Correct? So how many forward paths are there here? How many forward paths are there? So we have only one forward path. That means this is the only way to reach from R to C, undoubtedly. Correct? So this is the only way to reach from R to C, no doubt about that. So therefore, forward path 1, I can say, which is actually traveling from R as well as x1, undoubtedly x2, x3 node, and x4, x5. Of course, this is going to be C. What would be the answer here now? So the answer would be gain is 1, and then G1, G2, and then G3, and again 1 here, and G4. If you multiply all highlighted portions, G1, G2, G3, G4, what you will going to get here? So it's simple question, G1, G2, G3, and G4 here. Correct? Only one person has given the answer very fast, that is Hrithik Samala. Good, very good. Right? And anyway, Rohit also has given the answer. Fine. Other people make it fast. Now individual loop. Where is the individual loop here? So the very first individual loop, all of you can see here, that is this one. So here you can see it is all the way traveling like this, x3 to x1. Correct? x3 to x1. In fact, it started from x1, all the way it is traveling to x2, and then x3 it is coming like this. So I can say x1, x2, x3, there is an individual loop here. So that loop has a gain of how much? G1 here, G2 here, and minus H1. So let me write down here minus G1, G2, H1 here. Right? And moving ahead to the next loop, that is second loop, L2. Where is the second loop here? X4 here. So let me write down x4 and x5 undoubtedly. And then we have C here. So therefore, you can see x4 to x5 and then C all the way again x4. Correct? Then that would be considered as a loop here. So without any second thought, I can say this gain is equal to minus G3, G4 into H2. And you have to do very fast, and damn fast you people are. You have really completed, and next questions are very good questions. Don't miss that. So just wait for me. So L3 is going to be what? L3 you can start here. X5 you can start all the, or else you can start from X2 and all the way you can travel like this and then come back like this. Correct? So L3 will going to be having x2 definitely, and x3, x4 and x5. Correct? And what is the loop gain now? G2 and G3, H3. So minus G2 and G3, of course it is going to become H3 here. Correct? So these are the 3 loops we have here. Correct? Now try to evaluate what is the delta here first of all. So P1, that is forward path gain, is ready with us, and now we can say delta, it is equal to 1 minus sum of loop gains of individual loops. What are the loop gains of individual loops here? This is individual loop, individual loop, individual loop. So therefore 1 minus, it will become like G1, G2, H1, but it is minus anyway. Minus if you take outside, it will become plus, because minus is there everywhere here, right? So plus, what else you will going to have here? So you will be having like G3 and G4, H2 of course, and additionally what is there here? So that is G2, G3, H3, G2, G3 and H3 of course, and additionally minus is completed. Now it would be plus, right? Sum of product of loop gains which are not touching, 2 non-touching loops. So what are the 2 non-touching loops? Any one of you, can you tell me here? So L1 and L2 both are not touching. Why? here the path traveled by the loop 1 and path traveled by the loop 2, both are not going to touch. They are not having the same sign at all, correct? Or same node at all. They are not having same node. Then what should I say? These two loops are independent, right? So they are not touching. So what we should do? We should take the product of these two. So when we take the product of this, it's very easy to say that is simply like G1, G2, G3, of course G4, and then H1 and H2 here. Clear? H1 and H2. So that is actually considered as the delta, right? So what would be your transfer function now? P1 delta 1 divided by delta. Now we have P1. So P1 is known to you. Delta is known to you. What is delta 1 now? Now delta 1 is 1 minus individual loop gates which are not touching the forward path 1. Now you see forward path has all the way this many nodes, right? So there is no loop without touching this node, correct? So look at the loop 1, x1, x2, x3 which are there in the forward path line, correct? And x4, x5, yes, that is also there in the forward path. And x2, x3, x4, x5, that is also there in the forward path. This means that all these three loops are touching the forward path 1. If they are touching the forward path 1, we cannot have any loop gain without touching forward path 1. So this is 1 minus 0. So therefore we call this as 1. Now everything is known to you, that is P1. And so if you go ahead, what is P1 here? So G1, G2, G3, G4. Clear? So divided by delta 1 is simply 1. And of course the delta is going to be this much, whatever we have here. So what is the correct answer here? Of course you guys have already mentioned that. I'm literally sorry. Even today I'm feeling that I'm really very sorry. I mean very slow. Okay, B is the correct answer. Hope everybody got that. If any doubts, please ask me. I will going to answer, because I personally believe that as we need to discuss, I am discussing. Otherwise I could have been gone to some other concepts, but I need to go as per the syllabus. So let's go to the next question, which is one of the very hereafter good questions will start. Okay, these questions are not previous year questions, and what I am doing is yes, Hrithik is asking some question. As the loops having the negative gain by just B, yes, that is very easy actually. You can do like that, but I just want to explain the whole procedure, so I explained. But however, in the exam you can follow multiple approaches. In my case, I will not do this much. I will remove that H1 or H2. I will cut the feedback and look at the option and eliminate the options so that we can get the answer. Clear? Now this question seems to be easy, but the next question follows this question. So it is like a linked answer questions. Today we will going to solve the linked answer questions so that you guys also will really enjoy, because somebody is asking that, sir, please discuss the new questions. So I am discussing the new questions. So now you cannot use the formulas. As you all know that my class will go mostly without formulas. So please try to answer this question, all of you. Yes. So how to approach this question? First of all, so as you all know, a first order control system, look at that, it's clearly mentioned that control system means it is including feedback. Look at that, it is including feedback of static gain 1 and time constant of 2 seconds is subjected with a step input of amplitude 5 units. The time taken for the response to reach 50% of its final value is dash. Okay, so how do we approach this question? First of all, it is a first order system. So first order control system. So I can take this as a block like this. So it might be g of s by 1 plus j of s into h of s, whatever it may be. All the way, finally, it will have some static gain k divided by 1 plus tau s. And we all know that we will going to apply the x of s here, which is considered as the input, and y of s, of course, it will be here. And this question, with using formula, you cannot answer. You have to go from the basics. That's why I have kept this question. Now you should participate and tell me. Anyway, what is y of s by x of s now? That is the transfer function. Let me write down y of s by x of s all the way, k divided by 1 plus tau s here, and that would be equal to how much? So k, that is 1, static gain is 1 divided by 1 plus time constant is 2 seconds into s. Clear? 1 by 1 plus 2 into s. Fine. Then we can also say x of s is equal to how much? X of s is equal to 5 divided by s. Why? Because x of t is a step input of amplitude 5 into u of t. Correct? So therefore x of s is going to be equal to 5 by s. Any one of you got the answer? Earlier you guys are so fast, right? Now you need to show your speed to me. Okay? So very good. 1 by 1 plus s. Therefore I can write down y of s all the way equal to x of s into 1 divided by 1 plus 2 times of s, and that will be equal to what? Y of s could be written as 5 divided by s, correct, into 1 divided by 1 plus 2 times of s here. Clear? So if you continue this, I am very sure that it can be rewritten. In fact, y of s can be rewritten like this. So please see here, y of s can be written like 5 you can take outside, and it will become like 1 divided by s minus 1 divided by s plus okay, so e power minus 2t, right? So of course it will going to become like e power, if you take 2 outside and cancel and do all these things, it will going to become s, you take 1 by 2, it will going to become. Clear? So this is how it will going to become. Just try to rearrange the things. But as I was knowing that already the fact, so if you do the partial fraction, you will be getting the partial fraction, no problem. Otherwise, if anybody has the struggle here, or if you people are getting struggle, so then what we need to do, just write down like a by s here plus b by 1 plus 2s here, and find the values of a and b by using the partial fraction. I feel that all of you are capable to do this because this is elementary mathematics. Clear? Moving ahead with this, what is y of t here now? So can you tell me, Arvind Reddy, what is a and b here? Can you please tell me what is a and b here? Arvind Reddy. So if I am not wrong, a will come something like 5, and b will going to come like, so b will going to come like minus 10 here. Clear? Minus 10. Of course, just look at this calculation. But however, the final expression, I am very sure that, so the final expression after placing a and b and taking the Laplace transform of this, inverse Laplace transform of this, it will come like y of t is equal to 5 into 1 minus e power. What is the time constant? Time constant is 2 seconds. E power minus t by tau. Minus t by tau. So that is minus t by tau. Clear? This is exactly what you will be getting here. Am I right? Just check this, all of you. Arvind Reddy and Rohit Singh, as well as Karan Gupta, Rufina Begum, is it correct or not? Every one of you, please let me know y of t is correct or not. Now this is y of t, but what would be the final value here? So simple, final value, how can I say? At t is equal to infinity, we can get the value of final value. So what is that y of infinity here? Any one of you? So look at that y of infinity, I am extremely sorry. Yes, y of infinity is how much here? So y of infinity, I can say 5 into 1 minus e power minus infinity. Without any second thought, I can say this is 5. So y of infinity is 5. Correct? Y of infinity is 5. But what they are asking? They are asking the question that the response should reach 50% of its final value. Now this is your final value. Correct? So this is actually your final value. Very good. No problem. You cannot use any formula. Obviously, you need to follow the procedure only. Okay? Right. So this is final value. Now 50% of final value is how much? 50% of y of infinity is how much? 50% of final value is 2.5. Correct? 50% of 5, that is nothing but 2.5. So that means obviously after a lot of hard work, what we understood is yes, y of s or y of t must be equal to 2.5. At what time it will going to equal to 2.5? Any one of you, can you tell me the answer at least now? Because I almost made the equation. This is y of t expression. Now we are expecting at what time this will be equal to 2.5. Correct? So moving ahead, I can say 2.5, that is y of t at what time? So this will be equal to 5 into e power. What is that? Minus t by tau. So what should I say? Minus t we don't know, divided by 2 here. Correct? So taking this to this side, so it will become 1 by 2. Right? So I can say e power minus t by 2 all the way, this will be equal to how much? E power minus t by 2 is equal to 1 minus 1 by 2, so that is nothing but 0.5. Can anybody calculate this fatafat and tell me what is the value of t here? T here, Rohit and Karan Gupta, any one of you, please tell me what is the value of t here. I am waiting for your answer. Today I don't have calculators, so you must actually give the answer here. Okay? So please do it fast and tell me what is the value of t here. Can you make it for me? Please. Any one of you, what is the answer? Yes. So the answer is given like 1.38 second. Good. Very good. 1.38 second is the answer. Well, so you can easily understand that this is 1.38 seconds. So it seems to be why I have given this question is to make you understand that majority times you cannot use a formula. You know that there is a formula to get 98% of the final value. 98% of final value, if I ask, directly you can say the time is equal to 4 tau. There is a formula for that. And 63.2% means directly time constant. There are formulas for all these things, but they may ask the question like 50%, 30%, 40% like that. Now the next question is still better than this question. So I have given this question only to give the next question. Now this question I like this, and I will give at least 2 minutes time to you. Get the answer and tell me, and specially expecting the answer from Rohit Singh, R.L. Surfina Begum, Arvind Red. Okay, so please let me know. Yes, Rohit is asking a question. Sir, the time constant of 2 seconds we will get as 0.5. So we can directly substitute for I didn't understood you what you were saying, Rohit. The time constant of 2 seconds we will get as 0.5. What is that? Can we directly substitute? No, we cannot substitute for time constant. Why? Because you cannot get 4 tau here. The reason is they are asking 50%. You need to follow the procedure only. There is no other option here. Okay, so otherwise, Rohit, you please elaborate your question. I was not able to follow what you are asking. You cannot substitute directly. That is what I would like to say. Now this question, as I was saying, it is good question. You take time, but I want answer and correct answer from everyone. Okay, don't throw the stones on me. Take some time, but let me know the correct one. A first order control system of static gain 1 means the same thing, and time constant of 2 seconds, fine, is subjected with the step input of amplitude 5 units, same. The time taken for response to reach 98% of its final value, the initial value of the response is 2 seconds. Oh, Rohit, I am sorry. I am extremely sorry. I think you are asking for this question. Okay, you are asking about this question. No, that is the trick, na? Though many students, what they do, you know, 98% of final value. Sir is asking 98% of final value. As the time constant is given like 2 seconds, t is equal to 2 seconds, you may directly take that. So that settling time or 98% of the time, it is actually nothing but 4 tau. That means you may feel that the time required to reach 98% of the final value is going to be equal to 4 tau. And you may get like 4 into 2 seconds, that is equal to 8 seconds. So tell me, how many of you done like this? How many of you done like this? How many of you done like this? First of all, think logically. Do you think that this is correct? But I am sure 98% of the students, they will go like that only. They will go like that, but this is wrong answer. I would like to say this is wrong answer. If it is wrong answer, what is the correct answer? Have you noticed the fact here? Is it good question? Anyone got the answer? I would like to see the response from you. Why no one is responding to this question? So looking little bit tricky. Looking little bit tricky, na? So look at what we need to do, especially in this kind of systems. First of all, try to write the input and output clearly. Okay, so the input, as I was saying, the system is same like 1 by 1 plus 2s, which we have been discussing from the previous analysis. However, if you look at x of s, undoubtedly this is going to be equal to pi by s. We don't know what is y of s here, so we can directly use y of s, which is equal to x of s into 1 divided by 1 plus 2s, and continue to solve this one, right? So continue, then 40 is correct. No. If initial value is 0, 40 is correct. Good. Is this is a gate question? No. Hritik, this is not a gate question. When I was doing my masters, especially in process control lab, we find this kind of questions, and even these questions are better than gate questions. Okay, so that's why I'm saying that today you are going to see somewhat good questions. Okay, so please let me know. Y of s is equal to x of s into 1 by 1 plus 2s. Any one of you, can you get it now? Right. So those who are going with this, I'm sure you will not going to get the answer. So what you must understand here is control system static gain is 1. Now can you please tell me here, if at all, if I take y of s is equal to pi divided by s, clear? Pi divided by s into 1 divided by 1 plus 2s, correct? 1 divided by 1 plus 2s. Now what would be the final value of this? What would be the final value of this? Any one of you? What is y of infinity now? Y of infinity? Many people, they think like this. So the step input we are applying here. So x of t we are applying with the 5 as the input here. Static gain is 2. So the output will also have to reach to 5 into 1, that is going to be 5. Correct? So or else you can even see y of infinity can be written as limit s tends to 0, s into, very good, s into y of s. So what would be this value here? Again I can say limit s tends to 0, s into 5 divided by s whole into 1 divided by 1 plus 2s. Undoubtedly this would be equal to 5 only. That means final value is fine, right? So you are like a student of UD, sir. UD means what do you mean by UD? Target core. Good. 5 is going to be your y of infinity. That means it is a final value. Now he is asking the time to take 98% of the final value. Good. Okay. 98% of final value is how much? 98% of y of infinity is how much? Without any second thought I can say 98% of 5. Anyone of you, can you tell me? Target core, you haven't answered. UD means what? Okay, so 98% of 5, I can say this value is equal to 4.9, right? So 4.9 is the value that output should reach, right? But the problem is, many students what they do is, they will consider this system and they will find the inverse Laplace for this. And if you apply inverse Laplace to this, then you will get y of t is equal to 5 into 1 minus e power minus t by tau, that is t by 2, like what we got earlier. Clear? And what they do is, they will take this 4.9 and they will substitute here and make it like 5 into 1 minus e power minus t by 2. And if you solve all the way this one, then t will come like 8 seconds. Correct? So this is what most of the students they do. But definitely it is wrong answer. Why it is wrong answer? The reason is, this y of t you have done with considering initial conditions is equal to 0. Clear? Considering initial conditions are equal to 0. So if the output have to start from 0, then it takes 8 seconds to reach 4.9 volt. But output is already having 2 seconds before we apply the input. Correct? Output is already having the value of 2 before we apply the input. So we cannot approach in this way. In that case, you have to consider this as a simple RC circuit or first order system. Or just assume that we have RC circuit, right, where the capacitor is charging. And what would be the formula for the capacitor voltage, especially when we are having the initial input voltage? Any one of you? Because RC circuit, as I was saying, RC circuit is also a first order system. Correct? RC circuit, definitely it is a first order system. Correct? First order system. Then if you ask a question, write the capacitor voltage, right? So with the initial condition, how you will write here? So you will write this one as Vc of infinity plus Vc of 0 minus Vc of infinity, especially whole into e power minus t by t. Correct? This is what exactly we do. Am I right? So this is what exactly we do. Now we should apply this concept here. Why? Because we are having initial condition and final value both. Therefore, here y of t, the response must be written as y of infinity, that is y of infinity, fine, plus it is going to be y of 0, of course, minus y of infinity here undoubtedly into e power minus t by tau, that is anyway 2 seconds. So I am not going to again discuss all this stuff because it's already completed here. That is finding the final value and 98% of the final value, all these things you know, right? So now think logically and tell me, what is y of t expression? Still we haven't made it. So this is 5 plus initial value is how much? Initial value is 2 minus again 5 whole into e power minus t by tau. So this will come down to be equal to 5 plus it is equal to 5. I am extremely sorry, 2 minus 5, right? So 5 minus 3, just give me 1 second. Yes, 5 minus 3 of course into e power minus t by 2 seconds. Clear? 5 minus 3 into e power minus t by 2 seconds. Now think logically. If this is the case, 98% of y of infinity is 4.9 value. So therefore what should I write here? So 4.9 we need to equate to the left side here. So that's why I told you that today you will going to see good questions. 4.9 that will be equal to 5 minus e power minus t by tau. Now calculate the value of time and tell me what you will going to get. Every one of you, right? So this question was indirectly asked in Texas Instrument interview as RC circuit question to my friend. Excellent, Rohit. That's why I told you that, right? Even when we are doing this process control labs in IIT Madras, these kind of questions will be there. And listen, if this kind of questions comes in the exam, obviously majority of the students cannot answer these questions, right? Because most of the students, they will go for 8 seconds and they get stuck. That's where I am saying that we have to think one step beyond that. Then only you will become a champion. So the idea of champion series is to make you champions, right? So teaching again and again, showing the same picture again and again. What is the use of that? Let's think one step behind others. Then that will move. That will really put us better position. Correct? So Karan is so sincere student. Karan, just simply, I love you. That is very sincere student you are. Please let me know what is the answer. Just check other people. Arvind Reddy and Rohit, Rufina, Hrithik. Please see this one and tell me whether the T is correct or not here. T is what? Karan is saying 1.79. आप एक बार check कर दो क्या है, because it takes some calculation and I feel that you people are having the calculator with you. फटाफट जल्दी करो. क्या है ये time? How much the time will be here? 5 minutes, otherwise 6.8 seconds. Okay, so let me see why different people different answers. 0.1 here, 0.1 divided by 3, right? So I can say otherwise if you go forward this one, so it will come 3 into e power minus t by 2, that is equal to 5 minus 0.1. This is 0.1, therefore it is e power minus t by 2. I can say 0.1 divided by 3. 0.1 divided by 3, of course it is equal to 0.1 divided by 3. What would be the value? 0.033 or 0.34, right? Ln of 0.304, what is the value? 0.034 here, and that will come some value into 2. 6.8 I am getting, somewhere around 6.8. Yes, I agree. So I think most of you also got the same answer here. First of all, tell me, is it good question or not? Is it really good question or not? Every one of you trapped so easily, right? So most of you were saying earlier this is the answer, but this is wrong answer, right? So this is wrong answer. Is it good question or not? I need your comments. See, it looks like easy, right? That's where the IIT standard is. Question looks very simple, but you need to correlate. Yes, here we got initial condition. So when we have initial condition, in which way we need to solve? In control system, they don't teach with the initial condition, right? Because the transfer function what you are deriving, it is all the way by assuming initial conditions are 0, right? So but when we have initial condition, then what to do? That also you need to know, right? So this question involves the concepts of networks and control system. Correct. That's excellent, Hrithik. That is the way you should learn. There is no other subject like subjects are not independent. They will be related. Now I can connect circuit theory to amplifiers and analog electronics to control system. Everything can be connected at the end because it is engineering. You will read it as a term like engineering. You don't see like control system engineering and circuit theory engineering like that. These are subjects, so they can combine together to form the engineering. So therefore you need to play on the ground and connect everything, then you will really enjoy and the subject will be amazing. Clear? Very good, Rufina. So now let's move. Next question will be still interesting. So today only I prepared these questions by keeping, because I know that Rohit will come, Arvind Reddy will come and Karan also will come to the live, including Rufina also. That's why I was sitting and I prepared this many good questions. So please see this and let me know the next question here. Yes, Arvind, that's why classical control theory missed that, but anyway in state space we will do that. Now this is also a good question. Think logically. A second order control system, right, is modeled as RLC circuit. That means there might be a very complicated circuit or there might be a complicated device. We are making it as a RLC circuit. Okay, fine. Right, see, the resistor is variable. Very good. The resistor is variable and the voltage across the capacitor is considered as a response. See how clearly they have mentioned this, right? I mean, I only mentioned that. Find LC of the circuit to get the sustained oscillation of frequency 2 radians per second in its unit impulse response. Clear? In its unit impulse response. That is our first question. Second question is, if a 10 volt DC input signal is applied, then the peak value in the voltage across the capacitor is dash. Okay, then the peak value in the voltage across the capacitor is C. Right? You didn't find any blocks. right? So these are looking like theoretical questions, but they are not theoretical questions. They are real-time practical questions. Now we'll see how we can answer, right? So first of all, for this kind of question, try to write a draw a circuit diagram here. R, resistor, and of course we have inductor, and of course we have a capacitor also here, correct? So let me call this as a resistor R here, and inductor and capacitor here. Of course, we can say whatever the voltage we do apply here, let me call that as a supply voltage here, and let me call this as VI, and voltage across the capacitor is considered as a output voltage. So let me say voltage across the capacitor, that is VC of T here, and this is going to be VI of T here. Now can you tell me, if I go for the Laplace domain, right? If I go for Laplace domain, Dharwant is giving some answer, right? LC is 4, very good. No, LC is not 4. Arvind, you have made the mistake, just see here. So first of all, convert this into the Laplace form. When you convert this into the Laplace form, obviously this will become SL and this will become 1 by SC. Very good. And this will become VI of S and this will become VC of S, right? This also probably many of you know this, right? So how should I write now? VC of S, which is nothing but the voltage across the capacitor in Laplace domain, that will be equal to the total supply voltage VI of S into the impedance of the capacitor, that is 1 by SC whole divided by what you will going to have here. So the total impedance is R plus SL, that is the total impedance SL plus 1 by S into C, correct? So this is simple voltage division rule. Now we can say the transfer function what is required for is VC of S by VI of S. How can I write VC of S by VI of S? This, if you rearrange this, I am sure that you will going to get like this here. So 1 divided by LC will be there in the numerator here. Just rearrange this, you will going to get. That means take LCM and take LC outside and cancel. So you will be getting this very comfortably, S square plus R by L into S, of course, plus 1 divided by LC. And there is one important concept here, right? So you will really understand that. Just okay, whatever the spam comes in between in the comment section, don't worry about so much. So just let us go directly to the session here. So now all of you can see here, all the way we have 1 by LC here, 1 by LC here. Now think logically. I have given this question, very wantedly. What was the transfer function here? Guys, don't worry about any spam, okay? In the comment section, just focus on the class, right? So that means we are getting popular. That is the meaning of that, whenever spam comes, okay? So here we are having like 1 by LC whole divided by S square plus R by L into S plus 1 by LC. Now think from the analog electronics, control system, circuit theory. I repeat, analog electronics, control system, circuit theory, all three clubbed together, and look at the beauty of this. Now it was clearly mentioned in the very first question. See, find LC of the circuit to get sustained oscillation of the frequency 2 radians per second in its unit impulse response, and that sustained oscillation is possible, means with a constant amplitude, only if the resistance value is 0. Now I will tell you what is the meaning of this one. So inherent meaning of this is, so please try to see here. So if resistance R is equal to 0 ohm, clear? If the resistance is equal to 0 ohm, then what is the transfer function now? Can you tell me? Transfer function is voltage across the capacitor divided by the supply voltage VI of S, and that would be equal to what? 1 divided by LC, of course, and it will become like S square plus 1 divided by LC, correct? 1 divided by LC. How it is looking like? Anyone? How you can convert this and tell me now? So 1 by LC. Now we all know that the standard second order system transfer function. How the standard second order system transfer function will be there? So second order system transfer function, let me write down standard transfer function of the second order system, that would be written as equal to omega n square whole divided by S square plus 2 zeta omega n into S, of course, plus omega n square. Agree with me, right? So now what is not there here? When the resistance is there, and I am very sure that this factor became 0, right? That means zeta is equal to 0. So it says that I can say clearly, when the resistance is equal to 0, now if zeta is equal to 0, then it looks like omega n square, obviously whole divided by S square plus omega n square. This is possible, correct? This is possible. Any one of you, what is the answer here? 0.25. Okay, so you have mentioned that. Now he was asking that that sustained oscillation must have a frequency omega n that should be equal to for 2 radians per second, I think, right? So just let me tell you here, omega n square, obviously because when we make omega n is equal to 2 radian per second, omega n square will going to become 4. So therefore it is 2 radian per second. Now compare this with this transfer function here. Compare this with this transfer function. What you can say here? So 1 by L into C is equal to omega n square, or we can say 4. Therefore LC is equal to 1 divided by 4, which is nothing but 0.25. Getting the answer for this is easy. As Arvind is saying, 0.25 is the correct answer. But what is the concept we must understand here? What is the concept you must understand? Look at this. Suppose here this inherently says that when the resistance is equal to 0, it means that there is no damping in the circuit, correct? So that means zeta is equal to 0. Then this is called as a undamped system. Clear? Undamped system. Very good. So that means in RLC circuit, by chance if you are actually having undamped, by chance if at all resistance becomes 0, that means resistance becomes 0 means what will happen? It will look like a short circuit here, correct? It looks like a short circuit. Am I right? It looks like a short circuit. So what does it mean? Let me take a few minutes of time here to explain clearly here. So resistance is 0. So in that case I can say this simply as a short circuit here, correct? Now what are there in the circuit? You have only inductor and capacitor. You have only inductor and capacitor. Can I say when we have only inductor and capacitor, it behaves like dash. It behaves like dash. Rufina, now you should be fast. Audio is not coming. Why? Arnab Malik, is it okay now? Oh, I am sorry. I think now it's okay. Just look at that. Yes. Right? So I think it's clear now. Current. So what should be the condition here? Now when the resistance is 0, we have inductor and capacitor. Yes, this is a tank circuit, correct? Good. So it means that it is right, coming audio. Okay, very good. So very good. So now that means this is an oscillator circuit. Basically it is an oscillator circuit. If it is an oscillator circuit, our primary importance is, or we must understand that finally the voltage across the capacitor must look like a sinusoidal signal or sustained signal like this. Whether you apply step input, DC input, or whether you apply impulse input, it should be a sustained oscillation. And its frequency, this signal must have, because this is an oscillator now, and it must have a frequency of omega n is equal to 4, omega n is equal to 2 radians per second. Clear? That means it means whenever the resistance is equal to 0, it is behaving like a, I think he is spamming your audio. Okay, Rohit. So when the resistance is 0, it is going to behave like a LC circuit, or we must say oscillator circuit. And if it is behaving like a oscillator circuit, then it has to generate a sinusoidal signal, and it must have 2 radian per second. When it will behave like oscillator circuit? If there is no resistance here. What will happen in control system? In control system, if there is no resistance in RLC circuit, it means that the damping is 0. That means it is an undamped system, correct? So analog electronics is now saying that when R is not there, it is a tank circuit and it should provide the oscillator signal or else the sinusoidal signal here, which must have omega n is equal to 2 radian per second. And the same logic when we have taken it to the control system point of view, where we are getting zeta is equal to 0, and all the way we got this function. Now my question is, what will going to happen for the impulse response? Can you see here? What is the impulse response here? Guys, what is the impulse response? Think logical and tell me fast. So here, look at that. Look at that, take this one here, and this is going to be Vc of s divided by Vi of s here, and which will be equal to 1 by Lc. That is actually nothing but what? 1 by Lc is nothing but 4 here, right? So 4 I can say, this will be equal to s square plus 4. In fact, it could be written as a 2 into 2 divided by s square plus 2 square here. Clear? S square plus 2 square. Now, I have a question to you. If you apply impulse input, that is unit impulse input. So Vi of s is how much? If you apply unit impulse input, so VA of S is equal to 1. Then what is VC of S here? So VC of S is equal to 2 into 2 divided by S square plus 2 square. And when you take the inverse Laplace of this, what you will going to get VC of t? Tell me. Any one of you? Very good, Arvind Reddy, very good. So VC of t will going to become 2, and this looks like omega divided by S square plus omega square, isn't it? So that means it is 2 into sine 2t here. Clear? 2 into sine 2t. That means it is a sinusoidal signal, correct? It is a sinusoidal signal. That means the voltage across the capacitor is providing the sinusoidal signal with the amplitude of 2 and the frequency of 2, right? So this is what the conclusion. We got it from the control system. We got it from the control system by making zeta is equal to 0 and all these things. But looking at the analog electronics point of view through the circuit theory, what we had here, same logic here. So that means here also we know that already we know that we are going to get a sinusoidal signal here, correct? Why we need to get sinusoidal signal? Because we have only inductor and capacitor here. Clear? So are the things are clear? So it is really a good question. Have you really enjoyed it or not? You tell me. If you say enjoyed, then we will move forward, okay? Because everything depends on your response only, right? So have you really enjoyed it or not? Tell me. Is it good question? So we have seen analog electronics, control system, and then circuit theory also, right? This is one side of the story, current. Now look at the second question. Second question is very good. If 10 volt DC input is applied, then the peak value of voltage across the capacitor is dash. Very good. Now let's move one step ahead, right? So the problem here is, now zeta is 0 from the control system, we know that, and right now we have the transfer function as VC of S divided by VI of S, which is actually nothing but 1 by LC means 4 divided by S square plus 4, correct? This is what we are having. And when zeta is equal to 0, though we know that we are applying the step input. Why step input I am calling here? So look at what was the input we are applying here. So here we are applying the input of what? So 10 volt DC signal, correct? We are applying 10 volt DC signal. So when we apply 10 volt DC signal here, without any confusion I can write down, without any confusion, Vi of t is going to be 10 into U of t here, correct? So therefore, what should be Vi of S? Vi of S is going to be 10 divided by S here, clear? 10 divided by S. Now have patience and go with the basics. Have patience, go with the basics. Have patience and go with the basics, okay? You need not to do, very complex things. Do the simple things in a beautiful way that will going to solve the things, right? So VC of S could be written from here as equal to Vi of S, right, into 4 divided by S square plus 4, clear? So then I can say VC of S is equal to what? 10 by S, correct? 10 by S into, of course, you will be having 4 divided by S square plus 4. Now I will give this as a homework. Try to just take the Laplace transform of this. It won't take much time, or else if you already remembered how to do this, then you will directly get. I am writing directly because I know the answer, because I have been doing these calculations many times. So VC of t will be equal to, now the step amplitude is 10 into 1 minus cos omega n into t, cos omega n into t. This is what you will going to get, clear? So in fact this is considered as a step response of undamped system. I repeat, step response of undamped system. I repeat, step response of undamped system. If you want, you can do, take a step response of underdamped system, because I feel that you people know that, and there you substitute zeta is equal to 0, then you will going to get this response, clear? There are n number of formulas are there. You can go like this, otherwise even you can go like this also. Now no, Arvind Reddy, wrong. So VC of t is this. Now tell me, or plot the graph here, what you will going to get here? VC of t, if you plot the graph, what you will going to get here, right? So let us say there the catch is there. Now you all must understand that the DC signal what you have applied at the input side, look at that, the DC signal is how much? 10 volt DC signal you applied, correct? So 10 volt DC signal when we apply, right? So 10 volts DC signal when we apply, of course on the line you will going to have 10 volt here somewhere. This is 10 volt. Now when you look at this, can you tell me what is the minimum value and what is the maximum value? So the minimum value of this could be -1, correct? So if it is -1, then what you will going to get here? -1, if it becomes 10 into 1 minus -1, so it will be +1, so you will get 20 volt, 20, right? So there might be a chance that you can get 20 volt here. Now suppose if cos 2t is becoming like +1, then what it will going to become? In that case it will going to become like 10 into 1 minus 1, that will be equal to 0 volt. Clear? This will going to be equal to 0 volt. This means that clearly there is a scope here that the capacitor voltage can reach to 20 here from 0, right, via 10 here. Obviously it can go like this and then it oscillates like this. Clear? So that it clearly states that 10 is the DC signal in the capacitor voltage. 10 is the DC signal in the capacitor voltage, and above 10 there might be a scope to get another 10 here. This is actually considered as a peak. Above 10 you can get 10 here, or else you can expand this one. You can even expand this like 10 minus 10 into cos 2t. Then you will going to understand that in the signal we are having a DC value of 10 and the amplitude of a cos is -10 and +10, right? So therefore here this may be 10, this peak is 10. So overall net value, how much it will become? 20 volt here, right? And this peak obviously it is going to be how much? -10 here. So -10 plus 10, it will going to be equal to 0 volt here. Clear? It will going to be equal to 0. So what is the peak value that you can see in the capacitor voltage now? What is the peak value we can see in the capacitor voltage? Any one of you? What was the peak value? The peak value of the capacitor is, look at that, peak value of capacitor voltage or peak value of Vc of t is equal to 20 volt here. Clear? Peak value of the capacitor voltage is equal to 20. Now tell me what is the percentage of peak overshoot here? Percentage of peak overshoot is how much? Look at these calculations. Don't think like whether this is circuit theory, analog electronics or control system. Think logical and tell me what is the capacitor peak overshoot. You should get 10 volt. You should get 10 volt. But peak is providing 20 volt. So what would be the percentage of peak overshoot now? Percentage of peak overshoot, let me write down like this. Percentage of peak overshoot, let me write down like this. This is equal to how much? You got peak value as 20, but you must get final value like this. So 20 minus 10, right, divided by 10 is the one you need to get, into 100 in percentage. How much you will going to get here? You will going to get 100% peak overshoot. Correct? 100% peak overshoot you are going to get. Got my point? Now this is a fundamental procedure and you understood that Vc of t is equal to 20. But there is a chance to write directly here when the zeta is equal to 0. We all know that the percentage of peak overshoot formula is what? Percentage of peak overshoot formula is equal to e power minus zeta pi by under root of 1 minus zeta square here into 100 percentage of peak overshoot. Now when you substitute zeta is equal to 0, obviously it will going to become like 0%, isn't it? It will going to become, it will become 100%, I am sorry. So when you keep zeta is equal to 0, you will get 100%. Clear? So let me write down here 100% here. You will get 100% peak overshoot. Correct? So that means control system is also saying the same thing and circuit theory is also saying the same thing, that you will get 100% peak overshoot. That means what is the beautiful point that is lying if you look at the circuit theory point of view. Clear? Circuit theory point of view, if you go back and see, what will going to happen here is, if you have this kind of circuit and if you give 10 volt DC signal, 10 volt DC signal, there is a scope to get 20 volt here. There is a scope to get 20 volt here. Clear? There is a scope to get 20 volt. This is something unusual thing, right? Why you are feeling unusual thing? When you give 10 volt, how 20 volt will come here, right? That is a point you need to investigate now, because here if you look at our calculations are saying that both from the control systems point of view it is showing like 100% peak overshoot, and from the circuit theory point of view it is showing like 100% peak overshoot. Means if 100% peak overshoot really comes, there is a scope to get a peak value of 20 volt. Correct? Now I am asking that if there is a scope to get 20 volt peak voltage, how does it will match this one? Because I am giving only 10 volt, how there is a chance to get 20 volt across the capacitor, right? Right? So Aditi Pandey, do anyone know when the class ends? So do you want me to complete as fast as possible? Okay, just give me some time. So maybe in another 10 to 15 minutes it will be over. But I want you to get the complete concept out of this. So guys, have you got my point here? My point is, if you really need to get 20 volt here, peak value as per the JITA control system point of view or the circuit theory point of view, how come 10 volt DC supply can push 20 volt onto the capacitor? This is a homework question to you. Okay, now after the class, you people must think and comment in the comment section. Clear? Is it really possible or not? If it is not possible to get 20 volt peak value on the capacitor, then whatever you have studied so far, this and that will be wrong. But we are sure that this is correct and this is also correct. This means that here there must be a scope to get 20 volt even though when we apply 10 volt. That means there is a scope. There is definitely a possibility, right? Why and how, that you need to start thinking now. Clear? Right? From inductor, excellent. Clear? So now you must look at that. What happened in the inductor? At that time, what happened in the inductor, do you know? Let me tell you. Excellent. So at the peak time, if you look at, particularly at the peak time, one second. Yes, at the peak time, particularly at peak time, capacitor might be having 20 volt, right? You might have applied 10 volt, fine, no problem. But at the time, inductor also push for another 10 volt here, clear? So that means here minus and this is 10 volt and here you will be having plus, clear? So then this might be 10 volt, another 10 volt will come from across this one and that will finally balance here 20 volt, clear? So that is how the inductor will generate the EMF of 10 volt by the time when the capacitor demands the 20 volts of the peak value, clear? So then at the time when the capacitor is showing the maximum value of 20 volt to you, at that time if you go back and check, inductor might be pushing to give 10 volt where the capacitor is actually, source is giving 10 volt, right? Why it is happening? Because the demand of the capacitor is 20 volt, clear? So is it really a good question or not? Once again, you should like me. In fact, you should encourage me if it is really a good question. This is such a good question, right? So I'm very sure that you will not get these kind of questions anywhere. Am I right or not? Frankly speaking, correct? So really you enjoyed this question or not? So now you understood how the concepts are working here, right? So when you will going to get undamped system? When the resistance is 0, correct? When the resistance is 0, you are getting a undamped system, fine. But at that time, if you apply a DC voltage of 10 volt, capacitor is pushed to go for the peak value of 20 volt. How a 10 volt voltage can go for 20 volt DC voltage across the capacitor? That immediately you may be thinking. But you forgot that what inductor is doing there, correct? Inductor is actually adding another 10 volt and supporting the supply such that satisfying the capacitor. Ultimately, it is the inductor and the source voltage both will try to come together and give 20 volts voltage to the capacitor, clear? So that's why I told you that the questions will be interesting in today's session. Now this is one more question, you can take it here. So a second order control system is modeled as RLC circuit. The resistor is variable and the voltage across the capacitor is considered as a response, okay? Given that LC is 0.25 and R by L is 2 units, fine. All these things are so easy, right? Thank you, Arvind. Thank you, Rufina. Thank you, Karan. Right. So now look at that. If a 10 volt DC input is applied, then find the peak value of the voltage across the capacitor. First of all, what would be the transfer function here? Now the transfer function is one second. Now the transfer function is voltage across the capacitor. Of course, as I was saying, VC of S whole divided by VI of S, and we got like 1 by LC earlier whole divided by S square plus R by L whole divided by S into 1 by LC here, correct? So what is this? Anyway, LC is given like 0.24, so therefore I can say here, because these things are known to us, I don't think so you will really feel so much of difficulty here, but as per my responsibility, let me explain this, okay? So here we will be having 4 divided by S square. Now look at that, what is this? 2 units. R by L is 2 units here. So that is 2 units, 2 by S, 2S plus 4. Clear? Right? Karan Gupta sir, can you give this type of questions in DPP form in your Telegram group channel daily and at the end of the day? Thank you, Karan. First of all, you know, it is really encouraging, right? So usually what happens is, even as a faculty, yes, as I teach the circuit theory and control system and instrumentation in the same intense, I can connect all these topics, right? But obviously the students should come forward, right? If the students are demanding like you, then I am always happy, right? So I will give this kind of questions if you are so interested, no problem, or else we will take more number of questions like this even in our paid channel also, BYJU'S Exam, not paid channel, free classes we can take in the app. So you have to demand these things. Once you demand, then obviously you will go with this, right? Yeah, PDF may, may de dunga, don't worry about that. Right now, when we connect this to the standard second order transfer function, what you will be having here? Omega n square whole divided by S square plus 2 zeta omega n into S plus omega n square. A very easy question this is. Compare both sides. So then you will be having omega n square is equal to 4. Omega n is equal to 2 radian per second. I know that it will come plus or minus, but only we will take plus here, right? Plus 2 radians per second. That is 1 second. And 2 zeta omega n. Now when we compare this, 2 zeta omega n is equal to 2, right? So then obviously zeta will be equal to how much? 2 divided by 2 into omega n. What would be the answer here? 2 divided by 2 into 2 here. So it is going to be equal to 1 by 2. So therefore zeta will be equal to 0.5. So if zeta is equal to 0.5, zeta is equal to 0.5 in this case, correct? So that means it is the value of resistor, right? Value of resistor can change the game here. Clear? That's why it is given like a resistor is variable. So when the value of resistor changes here, then the system will move from undamped to underdamped, underdamped to critically damped also. Clear? So therefore zeta is equal to 0.5 here, and therefore I can say this is underdamped here, correct? So let me write down this as a underdamped system here. Underdamped system. Well, this is underdamped system. Agree with the fact that if it is underdamped system, tell me what would be the percentage of peak overshoot? Any one of you? Go back first. So percentage of peak overshoot is what? Percentage of peak overshoot can be written as equal to e power minus zeta pi divided by under root of 1 minus zeta square into 100. Any one of you, can you please tell me what is the percentage of peak overshoot now? Because the zeta value we know now, zeta is 0.5. Please let me know what is the percentage of peak overshoot here. Telegram link, please. Yes. Telegram link is IN Guru. I told you, either type like this or else type like IN Guru 2022. Good, right? So guys, if you are really so happy and so interested to come to the lectures, why not? We will have some sessions on the free classes on the app also, so that we all both can discuss together and solve number of questions like this, which connects analog electronics, circuit theory, control system, all. Okay, so I can do that if you are interested, right? So what is the percentage of peak overshoot? Can you tell me? Rufina, where are you? Rufina, Arvind Reddy, Adit Pandey, what is the answer for this? Percentage of peak overshoot? Yes, percentage of peak overshoot 16.3. GATE aspirant Devendra, today you missed wonderful session actually. You can ask the other students how beautiful questions we have discussed, right? So it is going to be 16.3. 16.3% is the peak overshoot. Now you must know what is the final value here. Usually percentage of peak overshoot is actually nothing but the final value, the peak value. That means peak value C of TP, that is considered as a peak value, minus C of infinity, that is considered as a final value, divided by C of infinity, that into 100 here. Clear? That into 100. And if you equate this to the 16.3%, 16.3%, then I can say clearly that peak value, which is considered as C of TP minus final value C of infinity whole divided by C of infinity, that is equal to 0.163. But what is the final value here? Can you see final value here? Yes, when you apply step input here, right, how much you will going to get final value? Because the DC gain all the way for this system, DC gain is 1, correct? Static gain is how much? Substitute S is equal to 0, then you will get 4 by 4, that is equal to 1. What does it mean? If you apply a DC input here, so if you apply a DC input of 10 volt here, you will have a gain of 1 finally. That means final value will become 10. Input value is 10, static gain is 10, DC gain is 10, sorry, input value is 10, DC gain is 1, DC gain is 1. So 10 into 1 will become final output, correct? So therefore, I can say confidently here, final value is going to be C of TP minus 10 divided by 10, of course that would be equal to 0.163 here, clear? So moving ahead clearly, I can say C of TP, that means C of TP is equal to 1.63 plus 10. So 1.63 plus 10, what is the answer? That is 11.63 volt, clear? So that means the voltage across the capacitor at the peak time, that will be equal to 11.63 volt, clear? 11.63 volt. Am I right? Just check this one once again. Karan Gupta, you went somewhere wrong. So please see here, usually here, this is considered as peak value. This is considered as a peak value, and this is considered as a final value, and this is considered as a final value here, right? All of you check this, whether the calculations are correct or not. I want, yes, correct, Rufina, very good. And I think you guys have done mistake by using some other formulas. That's why I told you that you need to use common sense first. Okay, time t, and we all know that the steady state value here is the 10 here, 10 volt. How I am getting steady state value? See, Vc of S, voltage across the capacitor, is equal to Vi of S. Look at that. This is your transfer function. Am I right? This is your transfer function. Correct? So if you move ahead and find the steady state value, what you will going to get? Vi of S into 4 divided by S square plus 2S divided by 4. Am I right? And if I say DC input is of 10 volt, then Vi of S is equal to 10 by S, undoubtedly. Correct? Then what is Vc of infinity here? So Vc of infinity could be written as limit S tends to 0, S into what you will going to get here? So S into Vc of S. Correct? So therefore I can say Vc of S here. Now if I substitute all these things, what is Vc of infinity? Limit S tends to 0, right? S into Vc of S is how much here? That is 10 by S. Obviously I can say 10 by S whole into 4 divided by S square plus 2S, of course, plus 4, and if you make it clearly, you will going to get 10. So 10 volt is going to be the final value that you must get here. 10 volt is the final value that you must get. Yes, I am really very happy to see this, right? 10 volt you must get here. Very good. 10 volt is the value, you must get it. Correct? So Vc of t, I am sorry. But you must also notice that this is an underdamped system. In underdamped system, what will happen? The response, step response will peak for something and then dance for somewhere like this, and then finally it will going to come like this. Correct? So now I am asking, what is this peak value here? So and this is going to happen only at the time here, which is nothing but TP here. Correct? Peak time. And that value now you will be getting here with the help of percentage of peak overshoot. How much we got here? Vc of TP is equal to 11.63. Correct? So therefore what should I say here? So 11.63 is the value that is going to be here. Now let us do the back calculations and see. This is the peak value here, 11.63 peak value, and this is your final value. Then let's calculate the percentage of peak overshoot with this graph. Percentage of peak overshoot, now it will be equal to peak value, that is 11.63 minus 10 volt divided by 10 into 100. Check how much it will be. It will come like 16.3% here, and that is exactly what you told earlier, that the peak overshoot is equal to 16.3%. Clear? Now everything is matching here ultimately. Hope you got the idea here now, right? So though I moved little bit fast, I feel that it is required here, then only you will really enjoy the class here, right? So yes, VC must, right, correct. So now Karan Gupta, Soumya Bal and all of you, please let me know, is it clear so far? 16.3%, the both the way you can do it here. Yes, yes. Soumya Bala 0.90 second. Yes, I think you have done the next question here, I guess. Correct? So what is the TP? So the peak time. Peak time is also very easy. Find the peak time. So what is the formula for the peak time? Because I think you know this question, right? So the peak time could be written as the TP is equal to pi divided by omega d. That is pi divided by omega d can be written as omega n into under root of 1 minus zeta square. Now we have all the values. We have omega n, we have zeta value. So if you substitute all these things, then you will going to get the peak time, and it is simply a formula based. I feel that all of you are capable to do this question, right? So what is the answer for this? Rufina, GATE aspirant, Arvind Reddy, Soumya, are you there? Soumya Bal, are you there when I was explaining the previous questions? Like inductor capacitor, when the resistor is equal to 0, how it will behave like an oscillator? Are you there at that time? Soumya Bal and GATE aspirant. Very good. Have you enjoyed that question? Yes, very good. So the answer to this question is 0.907, correct? So 0.907. That's the answer. First of all, have you understood, Soumya Bal, that previous question, like how inductor is supporting the voltage source to get a 20 volt across the capacitor, which is a peak value and all those things. That's a wonderful concept. I want you to go through those things. Anyway, 0.907 is the correct answer for this. And last question, I will leave it for homework to you. So please see, find the time at which voltage across the capacitor settles in between 9.8 volt to 10.2 volt. Clear? 9.8 volt to 10 volt. So 10.2 volt. What does it mean basically? 9.8 to 10.2 means, if you write like this, 9.8 to 10.2 means, so let us look at like this, assume that this is settling like this. 10.2 we can say like this somewhere here, and you can consider that 9.8 somewhere here. Clear? 9.8 volt and 10.2 volt. Basically what is this? This is a range of plus or minus 2% of band, correct, of band of final value. Clear? Right, bring these kind of questions in measurement. Oh sure, definitely Arvind Reddy. Okay, 2% of band, plus or minus 2% band of the final value. So that is very easy, right? So TS, because 10.2 if you see, it is 2%, 98%, 9.8 is the 98% of 10 volt, correct? So 10.2 is 1 or 2% of the 10 volt. That means 2% above the band or below the band. Clear? So then what does it mean? Brainwashing question. Good. TS is equal to 4 divided by zeta omega n. That is considered as your settling time. Clear? So you have everything. Just calculate and tell me what is the settling time here. Any one of you? It is very easy. Settling time, I just want the answer because all the way you have every value here, right? So because you guys are faster than me in the calculation, so please let me know what is the correct answer for this. Good that it seems to be almost around 30 students are there in the live. Very nice. What is the answer for this? Rufina? Yes, 2. Oh, this is simple, I think, right? So this is zeta is 0.5 and omega n is 2. Just check this once. You made somewhere mistake. 4. Zeta we are saying like 0.5 and omega n we got like 4 here, right? So 2, obviously it is going to be 2 seconds, right? So 2 seconds is the correct answer for this question. Clear? So that's the basic idea, right? But what is the purpose of speaking with these questions with the capacitor voltage is, now it is your duty to rethink in the orientation of circuit theory and control system. Both are not different, right? But we can connect these concepts. That is what my intention of the today's session. I hope you really enjoyed, the today's session to the great extent. And tomorrow we will going to see the questions on the stability criteria. Followed by that we will also see the questions on the root locus. Don't miss tomorrow class also, because as you know, my questions will brainwash your concepts. So definitely you will also enjoy tomorrow class also. Tomorrow we will going to meet at the same time, that is 9 o'clock. However, whatever the questions I have given as a homework to you in the previous slides, please do these questions. Even this is also one of the question. So please take this question and then solve that, and please mention that answer in the comment section. As I said, we will going to meet in tomorrow exactly at 9 PM to discuss the concepts on Routh-Hurwitz criteria as well as root locus. So guys, thank you very much once again. I hope you really enjoyed the session today. Thank you very much.